Problem number 44. A hexagonal lamina of side 25 mm rests on one of its sides on HP. The side opposite to the side on which it rests is 30 mm in front of VP. Hexagonal lamina 25 mm resting on VP. On VP it is resting on one of its side. The side opposite to the side on which it rests is 30 mm in front of VP. The side which is opposite to the side on which it rests is 45 mm 30 mm in front of VP. The side which is opposite to this side is 30 mm in front of VP, and that side is inclined at an angle of 45 degree with HP. Now this problem I would like to solve. It is resting on VP. Now a hexagonal we have to draw. Hexagon with 0.5, 25 mm, 25, 60. Next 25, 120, 25, 180, 25, 240. Next last will join with the other end. This is the endpoint symbol. Now it is resting on one of its side. We have to rotate this. Copy is made off, and we remove this. Right, copy should be made off when you are moving. Now we will draw the projector lines. 0.13 lines till it intersect XY line. Right, we will do the namings for these. Counterclockwise A dash, A dash, B dash, C dash, D dash, E dash, F dash, counterclockwise, and we review the arrow marks and join this line by 0.5 millimeter. Now we'll write top view, naming. When you are viewing from this side, A is visible and B is not visible. B is inside of bracket. When you are viewing from this side, F is visible, C is not visible. Next, E is visible, D is not visible. Right. Now the side opposite to this side is 30 mm in front of VP. We draw 30 mm line from this 30 mm. We will draw locus line and we will take the distance between these two lines. It is 43.3. Then we'll mark a point here, or you can directly arc by center point. Arc by center point. Click on this. 43.3 is the radius. Right. Now trim one side. Then join with 0.5 mm. End point of this will be joined with the center of that arc, and this dimension is 30 mm, and one more distance we have to take, this line distance, .5. Sorry, distance between this line, this line. Or we'll take dimension of this 21.65. Once again, arc by center point from this part to 21.65 is the radius. So we got now we got this, and we'll use the naming for that. This set is A into bracket B. Next, this point is F into bracket C, and this point is E into bracket D. And you can measure the angle. Now we measure the angle between this and this, 44 degree. 44 degree we should get, right, we got exactly. And draw the line, continuous line with 0.13, that is projector from A to B. A is here, B is here, A and B we got. Next, F and C, C is here, F is here. Next, E point, E is here, then D point. Now we'll join with 0.5 mm from all the endpoints. From this end point to this end point, this end point to this end point, this and this, all the endpoints. Now we check whether these are copying or not. Right, they are copying, and use the arrow marks. Right. Now the edge opposite to this edge is inclined at an angle of 45 degrees. Right. The edge which is resting is inclined at an angle of, can take this side or this side, no problem. We have this side, that is 0.13, angle is 45. Whatever the length you can take. Next we will move all these things. Right. Move copy made on. This resting edge should be on 45 degree line, and rotate it from this edge to this edge on 45 degree line. One more time we will do. This head point on XY line, rotate this edge on 45 degree line, and we'll draw the projectors from A point. A is here, B point, B is also here, at C point, C is here, then D point, D is here, then E point is here only, then F point, so we'll draw it, then we'll cut. So zoom area, trim, unwanted lines, fit. Now this is over. We'll draw the lines with 0.5 from A is here, is here, C, D, E, F. That's it. Then use arrow marks wherever possible. If not possible, you can leave, no problem. Right. This is how you have to draw, and angle will be given, that is 45 degree angle is given in the problem.